Okay, so now we're going to talk about information processing theory or models of attention and memory. Okay, so just like a computer, I'm not really familiar, I don't really know how computers work, so bear with me if anybody knows more, but the information processing approach, just like a computer works, you have some input devices like a mouse, um, keyboard, and I guess maybe a monitor. Monitor is more of an output, but anyways, these are all input devices, and you sort of input information using these devices, and that information flows to memory, and the central processing unit can also recruit information. That information can go into storage, or you can recruit information from storage. But then they come back, that information will eventually go back into the central processing unit or the memory, and then present that information through some output device, which I suppose is a monitor. Um, so just like, the idea is that we're also like information processors, right? And so in a similar way, there's a stimulus that goes into our system, right? And we pay attention to it, we perceive it. That information undergoes some sort of thought process or processes. And then there's some sort of decision-making process involved as well, which leads to some sort of response, right? Um, so we think of information store processing as the storage and manipulation or transformation of information. And the major goal is to specify or identify the processes and structures that are involved in cognition, right? So what is attention? How does it work? What is perception? What other thought processes are involved? What's the decision-making process look like? Um, and again, the assumption here is that the processing of the mind resembles the processing of a computer to some extent. Of course, it's not the same, right? We're not made of silicone, but that's there is more resemblance according to this approach than you would maybe think, right? Which again, we're going to get more into later. And this comes from advances with advances in information theory and theory of computation, right? The idea with information theory is that there is information in the world. There really is information. It's something that can be measured and it's quantifiable, right? And so with these advances, the mind was increasingly being viewed as in terms of a computer that processed information, and that information could be quantified. And so in computer science, for example, one may ask how much information can be reliably transmitted over an information channel. What is an information channel? An information channel is simply some sort of medium that transmits information from a sender to a receiver. Um, because of the mind was increasingly being viewed as a computer, cognitive psychologists started asking similar questions about the human mind. So, like, what is the channel capacity of a given channel, right? Now, I put this picture here. This is Shannon's law. I don't really remember why I put this up, but I guess I'm just showing that this is has to do with the with information theory, right? Shannon is the sort of pioneer behind information theory. Okay. Um, and so again, a channel in the context of the human mind would be sort of any type of perceptual system that you use to process information. For example, you collect visual information with your eyes, auditory information with your ears, right? Uh, tact, Tactile information with mainly your hand, but also the skin on your body, gustatory information via your taste buds, vestibular information. I don't know how, I guess that one just comes from your body movements, the way you feel inside, internal sense. That's also going to be information, olfactory information via smell, And proprioception is like information about your body. I think that's about like where your body is. So like I feel my arm being up in the air. I know how it's oriented, and that would be proprioception, knowing that. So yeah, as an aside, if a lot of people say that there's only five senses, there's way more than five senses. This is eight of them. There may be more, but I'm not entirely sure, right? So somebody says they have six senses, say you have eight. Um, and all of these sort of senses can be considered channels, right? Information channels. And so with this in mind, uh, I forget his now. I can't remember now what his first name is, but Miller, 1956. I'm just blanking on it. George Miller. He came up with what's called the magic number, uh, and this is basically he's trying to figure out what is the capacity of the human mind, and he found that basically it's about seven plus or minus two, right? So yeah, let me just say what I wrote. Adopting concepts of information theory or from information theory, George Miller, 1956 proposed an information processing bottleneck, right? So because the information channels uh, have some sort of capacity limitations, and those limitations yield some sort of bottleneck in terms of how information flows. And he found that we could only remember about seven plus or minus two items. And an item is it's just something that we're processing, right? An item could be something like a letter or a single digit number, right? It could be a word as well, right? Um, and so you could use like what's called chunking, right? So chunking is essentially combining information in a way that makes it easier to process and remember it. So this can be done by grouping items into chunks or relabeling the stimuli in some way. So, as mentioned in the book, the number 100 is 1100100 in binary, which would fill more than the decimal notation of 100, right? And this is why, for example, a seven-digit phone number is separated into three chunks because it's easier to remember those chunks than if all the numbers are just shown to you. And it also, as mentioned in the book, natural language is the ultimate chunking tool because words are essentially chunks of letters that, when formed, are meaningful. And here's another example of my animations are off here, but FBI, UNI, CEF, IRA, SAT, LCD, GRE. This is a 20 item string of letters, right? But of course, we can chunk these, to make them meaningful. And if we chunk these, we actually sort of compress 21 items into 6 items, right? So we do have processing limitations, capacity limitations, but those can be overcome to some extent when you chunk. Okay. And now, I guess in the next video, we'll talk about information processing models of attention.